This is part 2 of a 3-part lecture on MapReduce. The goal in this 3-part lecture is to be able to run a MapReduce job on Amazon's cloud services, the Amazon Web Services. The MapReduce program that we're going to use is called Hadoop. And in the first part of our lecture series, we talked about what MapReduce does to data. In this section of our tutorial, what we're going to do is we're going to implement the code that's going to be run on the cloud. So we're going to put wheels to the ground on trying to understand what these different components are in MapReduce. So what I have here is I have Eclipse, and Eclipse is a brand new workspace here. And what I'm going to do is I'm going to create a new project. It's going to be a Java project. I want it to be a Maven project, actually. Let's see if I can find that. I want a Maven project. The reason I'm going to do that is because I'm going to use Maven to load up my dependencies. And I will just take some default values here, and I will just call it the MapReduce demo and the MapReduce demo. Since I'm not going to be sharing this project, it's not going to be important that I set those carefully. All right, that should give me a project over here called the MapReduce demo. That looks pretty good. And the first thing that I want to do is I want to add the dependencies into my pom.xml file so that I have access to the Hadoop library. So I'm going to go to the pom.xml specific representation here, the literal XML, and I'm going to take the dependency that's present from JUnit right there, from JUnit testing. I'm going to copy it, and I'm going to replace the information that's there with the information for the Hadoop project software. So it's going to be org.apache.hadoop, and the artifact ID that I want is Hadoop-client, and the version that I want is going to be 2.7.3. How did I know that was the version that I wanted to use? The reason I know that's the version that I want to use is because I've looked at the Amazon documentation for what version of Hadoop is running on their cloud right now. Right now, it's currently running 2.73, and so I want to use 2.73 in the code that I write as well. If in the future the images that Amazon uses upgrade Hadoop to a different version, you'll need to change your version ID here as well. I'm going to reduce this scope that says testing because we're going to be writing this for live, for production code, not for testing. After I do that, I'm going to save, and I'm going to come over here to my project, and I'm going to update my Maven project so that it includes that library now. Okay, the next thing that I want to do is I want to create the class I'm going to work with. I'm going to create a class that is going to do word counting. So in our first example, what we did is in our first video, what we did is we looked at an example of using MapReduce in order to count the number of words in a document. And we'll do that for our simple example here. It's sort of the hello world of MapReduce. So for that, I'm going to create a new class that's within my source main Java directory. And I'm going to call that class, we'll call that class word count. I'm going to want a main function for it. And I think that's it. I don't want to inherit abstract methods. All right, and then I'll open up my word counter class. Now the things that I'm going to put into the word counter class are the things that are associated with a Hadoop MapReduce job. So the first thing that I need is I need an inner class, which is going to be a tokenized mapper class. So the mapper process is going to be within this class. It is going to be public, it is going to be static, and then it's going to be the tokenized mapper, and that is going to extend, and this is where we start looking at the types that we're going to have in our object. We're going to extend a mapper class, and we're going to use 4 generics. The input, it consists of a key and value, so it's going to be object and text, and the output of our map process is going to be text, which is going to be the word we're counting, and then an int writable, which is going to be the number, which is always going to be a 1 in this case. Okay? And you need to use the correct word. The correct word is extends, not extend. All right, so let's include the mapper class from Hadoop. So I just did command 1. I'm going to import org Apache Hadoop MapReduce mapper, and I'm going to import org Apache Hadoop IO, and I'm going to import org Apache Hadoop IO int writable. All right, so the object and text that I've just put there in that generic represent the incoming data from our really large input set. Now, because we're going line by line, the first part, the object, isn't very important. The second class, text, is the type of the data that's coming in. So we're getting a line of text at a time. So now let's implement the actual method that gets called for our map process. That has a signature of public void, the name is map, and the input that it takes in is the same class as what we just mentioned above, mapper object. So the first thing is going to be the object is the key, and the text type will be value. That's the input. So each one of those value lines is going to be an input of our incoming text. And we're also going to get a context that is the way in which we spit out our key value pairs. The context becomes the mechanism for doing that. We'll call that context as well. All right. So now what we need to do is we need to do the work of breaking up our input and spitting it out to our context. And so what we're going to do is we're going to tokenize our line of text using just Java string tokenizers. So we'll do a string tokenizer, call it st, and we'll set that equal to a new string tokenizer, and we are going to pass it in the actual value that we're getting in. And since it's not the string itself, we need to take the text, we need to extract from the text class the string that's wrapped by the text. All right, we're going to import our string tokenizer from java.util. And then we're going to create the object that we're going to spit out. So our output word is going to be text, and we'll call it word out. And that's going to be equal to a new text item. Now we also need to, that's our output key. Our output value is going to be an int writable. We'll just give it the name 1, and that's going to be a new int writable, and we'll just give it the value 1, because we're always going to be writing out 1. Now we'll just do a loop while st.has more tokens. We will set the string of our word out equal to the next token. And then now that we've done that, we'll just spit out our key value pair. So the way we do that is we say context.write, we'll write our word out and the value 1. All right. And we've got an error. Let me just evaluate this and see what's going on. This might throw an exception, so we need to include exceptions to our declaration up here, IO exception and interrupted exception. All right, so now what are some details here that we're ignoring? Well, one thing we're ignoring is the way in which the string is tokenized. Maybe we care about the way punctuation is handled, or something that's not the default setup of string tokenizer. Maybe we're worried about the encoding of the text file. We want to ensure that we're using UTF-8 or some other encoding. Those are things that we're ignoring for this example. This gives us the map process. The map process will read in one line of text at a time. Now we don't have to call that. The MapReduce infrastructure is going to call our function, and it is going to pass in text into our value class. And we're going to break it up, and we're going to write it out to the context. All right, that goes out, and whatever we write out is going to get aggregated, and what it's going to where it's going to get passed back in is into a reduce class. So we need to add a second class to our infrastructure. This will be where our reducer lives, and so this is it's got to be outside that class. This is also public static class, and we'll call this one the int. Let's call it the we'll call it the sum reducer, because it's going to take the sum of the different components that we are sum of all the ones that are coming in. Now, just like we have to extend the mapper class to declare what kind of types our keys and values are, we'll do the same thing here. And we'll extend the reducer class that's part of Hadoop, and we'll say that the keys and the values that are coming in are going to be text and int writable. Now, these two types these two types here, the input to our reducer, have to match the output of our mapper. Otherwise, it's just we're not using the infrastructure right. That's the way the mappers and reducers work. Then the second set of two classes here become the classes that we're going to write out. And we're going to write out text, which is the token that we're aggregating, and we're going to write out an int writable, which is the number of times that that word has occurred in the text. Just like above, we had a map class. It's the one that actually gets called from within this class. We're also going to have a reduce function here. Let me import reducer from org.apache hadoop.mapreduce reducer. Good. And then we'll go ahead and write our reduce class. So it's going to be public void reduce. It's going to take in the term at the head of the list, and it's going to take in an iterable collection that goes over our int writable. So this is the list of aggregated terms that have come in. We'll call this ones. And then we also have a context that we're going to be able to give us the ability to write this out to our final aggregate output. All right, so we need to keep track of how many times we're going to be writing out, and we're going to need to write that out. Let's see. This should be easy enough. I guess what we just need to do is if we know all the things coming in are ones, then we just have to say context dot write term. We're going to have to actually go through our iteration and figure out how many iterators are there. So let's do that. Let's have, let's use a long in case we have lots of different, in case we have a very large amount of numbers coming in. Oh, and if we're going to use a long, then we're going to have to change this to a long writable as well. All right. So initialize count to 0. We'll say for while iterator.hasNext. Sorry, not while. Let's see. So iterator equals ones.iterator. There we go. We'll get the iterator from the incoming iterator class. We'll make that a local variable called iterator. And we'll say while iterator.hasNext. Every time we go, every element in the loop, we're going to add 1 to the count, and we'll just move on down to the next one. Okay, good. So then we just need to create a new long writable. And we will initialize it with the count that we have coming in. We will import that type from org Apache Hadoop IO. And then we will write out the term and the output to our context. That is going to require us to include some exceptions, an IO exception and an interrupted exception. And we'll write that, and that's great. So this is the jar that's going to do the work for us. The last thing that we have to do is we have to create a controller that's going to be in the map class, and that controller is going to be what's going to actually start and stop our job along the way. So to do that, we're going to need to fill out our main class down here. And this is going to have the components of our different, of the Hadoop. This is where we're going to interact with the Hadoop infrastructure, and we're going to create the job that we want to have run and tell the Hadoop infrastructure where the different components are that need to be run for the map process and the reduce process. So let's start by creating a new configuration, and this configuration is going to be a Hadoop configuration. So we'll make a new one, and make sure you import the right one, org Apache Hadoop configuration. And then after that, we will read in the argument to our program, because we're going to have to pass in the file names that we're interested in working with through the command line. So this will be a list of arguments. And we'll use some Hadoop classes that will help us to input our command line arguments. Now what this parser does that's nice is it has the ability to separate out all the different components that are giving options to the Hadoop infrastructure from the options that are supposed to go to our Java jar. So we'll import org Apache Hadoop util generic options parser and add the throws declarations that we need to, an IO exception. All right. All right, now that we've got that, we'll just have a little error check to make sure that we have the right number of arguments. We want to have one argument, which is our input file, and one argument, which is our output file. So we'll say if other args.length not equal to 2, then we will put something out. We'll say usage input file output file. And since this we know it's going to be called word count, we'll go ahead and say word count input file and output file. And the way you communicate that there is an error to Hadoop architecture is you output a number other than 0. So that'll be our 2 error. All right, so this is the initialization. That should go fine. Now what we need to do is we need to set up our job. So the job that we want to run is a type called job, and the variable would be lowercase job. And the way we get a job is we use a static, we use a singleton pattern, and we get an instance of the job. We pass it our configuration and a name for our job, and we'll call it word count. Save that, make sure everything's good. Now we'll do the different components of our job. We'll set up the different components of our job. So for starters, we'll say what is the jar that our job is running. And it's going to be this one. So we'll use the reflection in Java and say word count.class. And let's see, why is it complaining about that? Because we called our class word counter. There we go. All right, so that's the jar that we're running from. And now within that jar, we're going to set the mapper class. And that's going to be our name up here, tokenizer mapper. Again, reflection. Give it the class name there, tokenizer mapper, set mapper class. And what do we do wrong? Did I spell it right? Did not spell it right. Tokenizer mapper. Tokenize. Okay, so we need to change it from tokenize or tokenizer. Let's settle on tokenize. Tokenize mapper. There we go. And now we'll set our reducer class. So say job.set reducer class is going to be equal to the sum reducer.class. Let's make sure we don't get any typos there. All right, and then one of the things that you do in Hadoop is you specify how many reduce tasks you want, and we will say we can pick however many we want. We'll in this case say set reducer set num reduce tasks equal to 10. So we'll have 10 processes in our reduce task. Okay. And we need to set our output class. The key class is going to be text.class. And set the output value class. And that will be long writable.class. All right, so we're just wiring all the plumbing here. Then we'll have to give specifications for how we want the input and the output to be handled. So we're going to say we want the file input format to add an input path, and we will, file input format. We'll add an input path, and this is going to be the first argument. We're going to say job, and then we'll create a new path from other args sub 0. So the first thing we pass into the command line will be the input path. Let's import org Apache Hadoop file system. And then we will set the output format. And we will add an output path. And this will be the second thing on our command line. And we will make sure that we import the right kind. What are our options here? MapReduce file output format. Lib file output. What did we import here? Let's see. Let me just double check to make sure that we get this one right. I don't think it's that one, actually. File input format I want is going to be org Apache Hadoop MapReduce file input format. And then the same thing, whoa. And the same thing here. Nope, I must have gotten that wrong because, is that what it's right? Sorry, pause here for a second while I figure out what I'm doing. Nope, I guess I was right. I guess I was wrong. The package for our file input path is going to be org Apache Hadoop MapReduce lib input. File input path, there we go. So it's the longer one. Org Apache Hadoop MapReduce lib output file output format. And what's our complaint? Set output path. Okay, great. All right. And then finally, we want to exit this. We're going to run the task by calling job wait for, here, what we'll do is say job.wait for completion. We're going to say true. We want to wait. This program won't exit until the job is done. And we'll say the status is going to equal the result of that. And if status, so if everything went well, then we're going to exit with a 0, which means everything went well. And otherwise, we're going to exit with a 1, which means we had some kind of an error. And see what our warning is here. Add a throws declaration, so class not found, and an interrupted exception. If we save that, we don't have any warnings or any problems right now. So what we can do now is we can test it. So to test it, we're going to need to have a file that we can test on. So let me pull one up. Okay, during that short break, I downloaded the text of War and Peace, a long novel, from Project Gutenberg, and you can see that it's here in my project alongside with the rest of my code. Now, the thing about Hadoop is that you can run it in a single node cluster. That means you can ask just your own computer to pretend like it's an entire cluster, just to make sure that everything is working okay in your code. So I'm going to go ahead and do that, and I am going to run this as a Java application, and it should ask me to create a run configuration. So it's looking for a project that has a main class, and I'm going to ask it to find word counter, and there we go. And we're running, and you can see that down here in the console it said that I have a problem because I didn't pass it an input and an output file. You know what? Actually, this isn't an output file. This is an output directory because we're going to write out one file for each reducer. So we'll have 10 files because we have 10 reduced tasks right here. All right, so now in order to pass those command line parameters, I need to look at my run configurations. Here you can see word counter, and I'm going to pass it arguments in here. And the program arguments that I'm going to pass in are going to be war and peace.txt, and then I'll also pass in output directory. The output directory will be named output. I'll go ahead and apply that, and I will run it. Okay, I got myself into a little bit of trouble by trying to change the output class on the fly. For various reasons, because the SumReducer class is used in several places, we're going to turn this back into an int writable to make sure that it is going to work okay. So let's go through here. Make sure that's int writable, int writable. Let's change our count into an int. And then down here, let's change our output value into an int writable as well. All right, so I changed long writable to int writable there, and I made count an integer, and I made our output be an int writable. That's where I wrote it there. Then down here in our output class, I did int writable. So now if I come over here and I refresh, I will get rid of my output folder. And now I will run my word count class. And if all goes well, output will be opened up. Great. And now we have 10 different results along the way. So if we open anyone up, they'll have different words in them depending on which collector got them. So now we can delete this. And we can change our run configuration to take war and peace instead of input. And apply that and then run it. And that should take all the input of war and peace and begin to parse it. Now this is a big document, and so our parts file are going to be particularly large. And this might take a particular amount of work. So while it's running, let me just go through and point out a few things that I've done to my project to make sure that it's going to work. So for starters, let's look here at app.java. This was something that was built for us by our template code. That's extra. We don't need it, so I'm going to go ahead and delete that along the way. All right. Meanwhile, in our pom.xml file, which I'll open up here, in our pom.xml file, I did two things. First of all, there was a dependency here for JUnit, and I removed that dependency in the process of debugging. And so now between dependencies, you should only have one thing there, that org Hadoop Apache, org.apache Hadoop. The other thing that I did is I specified the version of Java that I wanted to use. And for that, I added this code here. I added tag build, tag plugins, tag plugin, tag group capital ID, org.apache maven plugins, /group ID, artifact ID, maven-compiler-plugin, artifact ID, version 3.7.0 /version, configuration, source 1.8 /source, target 1.8 /target, and then close out each of those tags. Then I'm going to click in that file and go under source and format to format the XML file. Now, if you save that and you don't have any warnings, then you have an equal number of matching and closing tags, and everything should be fine. So, two changes, got rid of JUnit and added this Maven dependency on 1.8. After you do that, you can come up here and right-click on MapReduce demo, and under Maven, do update project. And after you do that, you should see that your system library updates to 1.8. Now we have this source folder along here that had test code put in it automatically by our template builder. So we're going to go ahead and remove that from our build path. So I selected it, coming down to build path, and say remove from build path. Now on top of that, I'll just leave it like that. That's fine. Okay, now I'm going to refresh our directory, see how our job is doing, look at our output, And we can see that our output now has tons and tons and tons and tons and tons and tons of words that have been collected from War and Peace. Okay, so in summary, what we've done in the second part of our MapReduce lecture is to go through and implement the code that we want to use on our cluster. The first part we talked about MapReduce as a concept, and this one we did code, and the final thing that we're going to do is we're going to put this onto the Amazon cloud and run it there. So thank you for your attention. I'll see you in a second when we put it up on the cloud.